The fundamental particles, you have to understand the concept of the basic or the fundamental particles. What are the fundamental particles? The fundamental particles are divided into two main classes. One is called a lepton family, another one is known as the quark family. And you have to learn the names of these. The fundamental particles can be a lepton family or a quark family. How we categorize them? Even though some quark and lepton together can experience a weak nuclear, but those particles which are experiencing a weak nuclear force, mainly, we call them as lepton family. And those particles which are experiencing a strong nuclear force, most of the time, we call them as quark family. You have to learn the name of these members in the family, like family of the particle. The electron family consists of 6 particles and their antiparticles. And same thing, the quark family consists of particle and antiparticle. So we have electron, neutrino. You have to learn these names. We have tau neutrino. NEU is a neutrino. This. And we have muon and muon neutrino. These are the fundamental particles which all of them experience a weak nuclear force. And with this, we have their antiparticles. Like 6 particles are there and 6 antiparticles. What are the 6 antiparticles? The antiparticle of a proton is called positron. I will explain the difference between them, the difference between electron and positron. And then we have anti-electron neutrino. We have anti-tau neutrino. We have anti-muon. And anti-muon neutrino. So we have the particles and their antiparticles. What does it mean? What is the difference between the particle and the antiparticle? The difference between a particle and antiparticle is their charge. Like example, we say the relative charge of electron is -1. So what will be the charge of a positron? Positron is antiparticle. And how to represent the antiparticle? We represent by the same symbol but with a bar. So what will the charge of anti-electron? The anti-electron or a positron will be +1. So the main difference between the particle and its antiparticle is the nature, the charge. That they have the same mass, but their charges are different. So, and all of them, these lepton families, they all experience a weak nuclear force. The interactions are always with a weak nuclear force. Then we have a quark family. The quark family consists of up, down, top, bottom, charm, strange. These are the names given to the particles. And what about their antiparticles? The antiparticle will be anti-up. This will be anti-down. This will be anti-top. anti-bottom, anti-charm, and anti-strange. So for every particle, there is an antiparticle. The difference between a particle and antiparticle, the only main difference is the charge. They have different charges. They have same masses, they have same spins, but they have different charges. Like example, the symbol of electron is E. You have to learn the symbol. So the symbol of the positron is E bar. The symbol of electron neutrino is a mu, like this is actually, this is called a lambda as well. You have learned this lambda. This is also a lambda. One is a capital lambda, another one is a small lambda. So this is a small lambda, E. And then this will be the symbol. The symbol for a tau, these are all Greek alphabets. The symbol for tau neutrino, this will be anti-tau neutrino. Symbol for muon, it's mu. And for anti-muon, it will be mu bar. Muon neutrino, so this will be a muon neutrino, and this is anti-muon neutrino. So for every antiparticle, what we did, we just put a bar, the same symbol we use, but we put a bar. So electron symbol is E, electron neutrino symbol is mu E, tau symbol is like T. Yeah, muon symbol is same like micro. We use a micro, the symbol for a micro. That is the same symbol we are using for a muon. So this is like a micro. And what about this? The quark particles, which are up, down, top, bottom, charm, strange. So first letter is the symbol. In chemistry, you use the symbol for electron is E negative, not E bar. That is E negative. You can use this like E negative here. And then if you use a symbol, you will write E positive here. That is also a way to represent. But it's not bar there. Same way, if you want to write the symbol for anti-up, the anti-up will be up bar, anti-down, D bar, top T bar, B bar, C bar, and S bar. These are the antiparticles. What is the difference between a particle and the antiparticles? The particle and the antiparticle, they have different charges. You have to learn. You have to learn the charges of each. Electron is -1, positron is +1. This is a relative charge, not actual charge. Electron neutrino does not have charge, anti-electron neutrino no charge. Tau is -1, tau neutrino is +1. Neutrino does not have charges. Muon neutrino is -1, muon is -1, anti-muon is +1. And muon neutrino does not have a charge. Anti-muon neutrino does not have a charge. What about the charges of the quarks? It is for, see, the positive degrees, if it is up, top, or charm, these are the positive degrees. So it will be +2/3. So this will be +2/3, the total charge. This will be +2/3. This is a positive degree, +2/3. This is a positive degree, +2/3. And down, strange, bottom, so they have the charge -1/3. So -1/3, -1/3, and -1/3. So down will have a negative charge and 1/3. Bottom is having a negative charge and -1/3. Strange is also having a negative charge and -1/3. And what about the antiparticles? The antiparticle, if up is +2/3, anti-up will be -2/3. Opposite. If down is -1/3, anti-down will be +1/3. If top is 2/3, anti-top will be -2/3. If bottom is 1/3, -1/3, so the anti-bottom will be 1/3. If charm is 2/3, anti-charm will be -2/3. And strange is -1/3, so anti-strange will be 1/3. So here we have the particles and the antiparticles with their charges and the symbols. And what is the difference, main difference between a particle and antiparticle? they have different charges as well as the opposite spins. Is it clear? It's mainly related to memorizing the particles and their antiparticles. You have to learn this. Anyone having a doubt or a question till this point? So as you can see, the symbols are written here for electron, muon, tau, antiparticle, positron. So this is about the quarks. As you can see here, if we have up, it will be plus 2 by 3, down, it will be minus 1 by 3, strange, negative degree charm, positive, top, and then we have a bottom. These are the charges on them. And this is a comparison of the mass. The symbol of the particle, like this is a quark family, up, down, strange, charm, bottom, top. This is, I ordered them in terms of the masses. What you see here, the unit of the mass is mega electron volt per c square. The SI unit of the mass. How to know the charges as well? You have to just memorize the charge. For up, it is positive degree plus 2 by 3 for a quarks. For down, which is a negative degree, minus 1 by 3. And this is minus 1 by 3 times. This is a relative charge. So actual charge is 2 by 3 times 1.6 into 10 to the power minus 19. That is the actual charge of this, the actual number. But we consider 1.6 exponent minus 19 as a unit, a relative. So that's why we just write plus 2 by 3. But actual value is 2 by 3 times 1.6 exponent minus 19 Coulomb. So you have to know the charges as well for these particles. So as you can see here, this I categorize in terms of their masses: up, down, strain, charm, bottom, and top. The top quark is having the highest mass. The units are given in mega electron volt per c square rather than in kilogram, because for subatomic particles we normally represent. How we got this unit? There's a Einstein equation for mass energy change, E equals mc square. So if I need the mass, so it will be energy divided by c square will be equals to mass. If we represent the energy in mega electron volt and we have the c square, it's already as it is. So what will the unit of the mass in that case? The unit of the mass will be mega electron volt per c square. But right now we'll not go in detail how to convert mega electron volt per c square into kilogram. This is just a unit given with respect to the equation. Instead of giving in kg, the masses are given in mega electron volt per c square. So which is having the highest mass? The top quark is having the highest mass. And which is having the lightest? Up quark is the lightest. So a basic fundamental interaction whenever it happens between the particles, a particle can be a category of a quark or it might be a lepton.